right, so today we are going to talk a little bit about chemistry. And I know that this is biology, but we need to be aware of some simple chemical um, terms and concepts so that we can better understand biology. Okay, so chemistry is the scientific study of substances, chemicals, and how they react with one another. And of course, our bodies are made out of chemicals, so we have lots of chemical reactions going on within our bodies all the time. Hence why we need to understand chemistry. Okay? Processes of life are chemical reactions. So we're not going to get super in depth, but we do need to understand some basic principles. So we have atoms and elements. And we have something called matter. Matter is anything that has weight and occupies space. Matter is composed of chemical elements. Chemical elements are substances that cannot be broken down by chemical means into simpler substances. They are the elements that we find on the periodic table. That chart that has all those letters and numbers, those are all elements. Such things as carbon, hydrogen, nitrogen, sulfur, helium, magnesium, sodium. All those cool things on that periodic chart are elements. And 26 of those are found in the human body. We need to understand what an atom is and its structure. An atom is the smallest unit of an element that can participate in a chemical reaction. So elements are made up of atoms. Atoms of the same element act similarly. Atoms of different elements are different in size, weight, and how they react with other atoms. So atoms that are all found in carbon react similarly, but they react differently than those atoms found in oxygen because they're different. They're in a different element. So in an atom, we have 3 subatomic particles. We have protons, neutrons, and electrons. Protons carry a positive charge, neutrons carry a neutral charge, and electrons carry a negative charge. And this picture is showing you how an atom is set up. So that center blue part is the nucleus. And within the nucleus, we find the protons and the neutrons. And in a stable element, the neutrons and the protons are equal. And then we have electrons that are circling around the nucleus. And those are the little pink balls that we see on what we call orbits. This is showing you carbon. Carbon has 6 protons, 6 neutrons. Its atomic mass is 12 because we add the protons and neutrons together to get the atomic mass. And then we have, in this case, 6 electrons circling around. That first orbit or shell holds 2 electrons. The second and the third can hold up to 8. So technically, carbon does not have a full outer shell. That outer shell is sometimes called the valence shell. 4 more electrons could fit in that shell. And that is how things bond, because the shells want to be full. So they look for other atoms and elements to bond with in order to fill their outside or valence shells. So, the overall electrical charge of an atom is neutral. The protons equal the electrons. The atomic number is the number of protons. And the atomic weight, or the atomic mass, is the sum of the protons and neutrons together. And then there is something called the chemical symbol. And this is the letter, or two letters sometimes, that denote a shortened name of the element. So we use H for hydrogen, we use C for carbon. There are things called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. Therefore, they have different atomic masses. So carbon, the one we just talked about with the 6 and 6, is carbon-12. But there's such a thing as there's an isotope of carbon that has 7 neutrons and 6 protons, which is carbon-13. That is an isotope of carbon-12. If these isotopes form a chemical element that is radioactive, they are called radioactive or radioisotopes. So I said that these elements want to bond with other elements, right? And they do. There are things called molecules and compounds. A molecule is 2 or more atoms that are chemically combined. Here are 2 examples: O2, which is 2 oxygens, or NaCl, which is what we call table salt. Na, sodium, Cl, chloride, sodium chloride. The smallest unit of a chemical compound that exhibits the properties of a compound. That is what a molecule is. And a chemical compound is a substance composed of 2 or more elements chemically combined in a fixed ratio, meaning they always come together in the same way. And they come together through chemical bonds. Force of attraction between 2 atoms that allows them to join and form a molecule. So this is what I was talking about. When they have open spots in those valence shells, they can bond with other elements that have open spots in their valence shells. So atoms combine to fill their valence shells and become more stable. If there are open spots in their last valence shell, they are unstable. Hence, why they are looking to bond with another element to become more stable. And there are 3 types of chemical bonds: ionic, covalent, and hydrogen. Ionic bonds are formed between 2 ions with opposing electrical charge. An anion is a negative charge, and a cation is a positive charge. NaCl is an ionic bond. Na, it has a positive charge, or is a cation, and chlorine is a negative charged, and it is an anion. So they come together to make an ionic bond. Once a cation and anion are formed, the opposing electrical charges create a force that holds the ions together, and this is an ionic bond. And that is what we see in NaCl. Here is a picture of that. So Na, if you look here, has 1 pink in that outer valence shell. Chlorine has 1, 2, 3, 4, 5, 6, 7. Well, isn't that handy? Because chlorine wants 8. So they can bond together with that 1 valence electron from Na, basically coming over and completing the Cl's valence shell. So it's not that it loses it, it's that now they have formed a unity, and they are going to use those electrons between the two of them. So sodium plus chlorine becomes sodium chloride, an ionic bond. Ionic compounds dissociate when they dissolve in water. Okay, that makes sense too, because salt, table salt, can dissolve in water. There you go. These are called electrolytes because they can conduct electrical current in water. Composition and concentration of electrolytes must be kept within narrow limits within our body for our body to function correctly. We do not want our electrolytes getting all crazy, or we will not be doing well. We have a very narrow limit of movement for these electrolytes within our body. Then there is something called a covalent bond. These are chemical bonds between two atoms that is formed when you have sharing of valence electrons. The other one was kind of a steal. In the ionic, you can think of it as someone kind of stealing. The chlorine kind of sucked that one over. He kind of stole it. In this case, they're going to circle around all of the atoms. So this is H2O. This is one oxygen and two hydrogens. This is water. So in every water molecule, you have one oxygen and two hydrogens. And what happens is the oxygen is stronger than the hydrogen. So although the electrons circle around everyone, they spend more time around oxygen because oxygen has a greater pull. It is stronger. But technically, covalent bonds share electrons. Ionic, there is a steal. And then we have the weakest of the bonds, which are the hydrogen bonds. And this is a weak bond between a positively charged hydrogen atom and a negatively charged atom in a different or same molecule. This occurs when the shared electrons in the covalent bond spend less time around H and more time around the other atom, which might be oxygen or nitrogen. What happens is then the hydrogen becomes slightly positive while the other atom becomes slightly negative. The reason that is because electrons are negatively charged. So if they are spending more time, if there's more negative entities around the oxygen or nitrogen, it will be more negatively charged. And the hydrogen will have less negative entities around it, therefore it would become more positively charged. We have to remember that electrons are negatively charged. Here is a picture of a water molecule. A water molecule we said is covalent, and it is. The bonds between the two hydrogens and the oxygen are covalent bonds. But we know that water isn't just one molecule of water. There's many molecules of water, and different water molecules stick to each other through hydrogen bonds, which are the little dots of red that you see. Those are denoting the hydrogen bonds. So there's a lot going on in water. There are hydrogen bonds combining molecules of water together to make more water mass. And within each molecule of water, we have covalent bonds. Chemical reactions occur when bonds between atoms form or break, yielding new combinations of atoms. And there are two types of reactions: synthesis, which means basically production, and decomposition, which would mean the breakdown. And depending on the exact type, some of these reactions can be reversed. Most of them can. So if something happens, it can actually be chemically reversed the exact same way that it went. So that is going to end our chemistry lecture. Like I said, we're just briefly going through it so that we can have a little bit of knowledge to apply it to our biology.